Assalamu alaikum. A lot of you, they ask me about the calculation and how they can do the calculations. So here I will just do previously or do some calculation. I will do the first law of the laminar and first law of the turbulence. So for the turbulence, it will not be I will take the numbers, but I don't think it will be the good numbers, which is the Reynolds number. As you know, to be the flow is turbulent, that means the Reynolds number is more than 2300. That means it's turbulent. And for laminar, it's supposed to be less than 2300. So for here, the Reynolds number that I will get, I think is too small, and that means there is a problem during the experiment doing. So first of all, we have the data that we got from the experiments. Here the head loss that we got is 17, and 17, this one is centimeters. So the most of the units that we have in here, it's in meter. So I prefer to convert it to meter, which is gonna be 0.017, and here we have it in millibar. We have to convert it to bar first, which we have to divide it by 1000 to be in bar. Then we're gonna convert it to the centimeters. To each equal centimeter, we have to pressure times 10 to the power 5. Then this one is gonna be meter. From meter, we have to convert it to centimeters. That means I have to multiply it again with 10 to the power of 2. Divided the row it's mean 1000, which is water, times the gravity, which is 9.81. This is gravity, this is the row of water. Then we can get the centimeters, the measured head loss. So first I will do what we have to do here is to find the volume flow rate. The volume flow rate here, it's liter per second, and we have the volume and we have a time also. So just divided the volume by the time, but don't forget to put times 10 to the power -3. So from here I will do it. It's gonna be 0.5 times 10 to the power -3 divided by 44. I got 0.01136. 0.01136 times 10 to the power -3. So the volume flow rate, it's equal volume over the time, which is 0.5 times 10 to the power -3 over 44 second. Then I got 0.11, so 0.01136 times 10 to the power -3 liter per second. So first I have to convert from liters per second to meter cube per second. When I do that, I have to multiply it again with 10 to the power -3 to be in meter cube per second. I have to multiply with 10 to the power negative 3. So the total is gonna be 0.01136 times 10 to the power negative 6 meter cube per second. Then now I have to find the area. The area that I got here is the diameter, which is 0.003 meter. So the area is pi over 4b squared. Pi over 4, 0.003 square. Then it's gonna be pi over 4. This one it's gonna be 7.0, almost 7 times 10 to the power negative 6 meter square. So the volume flow rate, if I divide it by the area, I got the velocity, which is meter per second. That's what we need in the next step. So from here, the velocity equal 0.01136 times 10 to the power negative 6 over 7.07 times 10 to the power negative 6. I got 1.61 almost times 10 to the power negative 3. It's meter per second. So I can write it here again, 1.61. So I will write it under the velocity directly because this numbers take the space. So 1.61 times 10 to the power negative 3. Then I will find the Reynolds number. The Reynolds number that we have the equation here. So the Reynolds number is rho times the velocity. So it's velocity, which is regular V, times the D diameter over the mu. So the rho is 1000, which we talk about water, times the velocity, that's what we got, 1.61 times 10 to the power negative 3, times the diameter, which is 0.003. The total is over the mu, which is 8.9 times 10 to the power negative 4. What I got is 5.43. So this one is less than 2300, which means it's laminar flow. So that is correct. That means this one is correct. It's laminar. Here we 5.43. Now to find the laminar flow, which is the F equal 64 over Reynolds number, which means 64 over 5.43 This one is 11.786. Then I will calculate the head loss. Okay, here don't forget all that we worked in here with the meter. So after I find it, it will be meter. Then I have to convert it to the centimeters. So from here, I got the F times L times velocity square over D times 2G. So the F is 11.786 times the L is given here 0.4, then times the velocity, that's what we got, 1.61 times 10 to the power negative 3 square over the D that also is given, it's 0.003, then times 2 times the gravity acceleration, it's 9.81. By the calculator, 11.786.4 times 1.61 times 10 to the power negative 3 square over 0.003 times 2 times 9.81. Okay, see the difference is, it's huge. It's too much, which is 0.2076 times 10 to the power negative 3 by the meter. Then I have to convert it to centimeters by multiply it with 100. Then I will got 0.02076 centimeters, which means a huge difference, because what we got 0.02 and the measure it was 17, regular 17. So there is something was wrong with the experiments. So the number that I have to put it here, it's supposed to be in centimeters, so this number, or just change the unit to meter, and you have to change this again to meter. So I prefer to keep it in centimeters and put the numbers in centimeters. So it's going to be 0.02076. This is the first part for the laminar. Then I will do it again with you for the turbulent. I will do just the first row, and you have to show me your calculation with the second row for the laminar. Also, you have to fill all the tables to give the full mark. So don't forget to fill the tables. Don't keep it just for. Don't keep it only just for the shade row. So here I will complete with the turbulent right now. So I will convert 0.2 millibar to the centimeters first, which is H equal P times 10 to the power 5 times 10 to the power 2 over 1000, or just make it samples first. Rho times G times 1000 which is gonna, this 1000, it's mean the convert from millibar to bar. So here it's equal 0.2 times 10 to the power 5 times 10 to the power 2, then 1000 times 10, sorry, times 9.81, then times 1000 again. It will be 0.2 times 10 to the power 5 times 10 to the power 2 over 1000 times 1000 again times 9.81. So what I got is 0.2038 centimeters. So the first one, it was 0.2038 centimeters. So let's start now with the second tables. I just convert now with the first row, the first column with the first row, which is 0.2 to centimeters, from millibar to centimeters. So right now I will find the volumetric flow rate, which is 0.5 times 10 to the power -3 over 29. Here I got 17.24 times 10 to the power -6 liter per second. Then I have to convert from liter per second to meter cube per second by just multiply it with 10 to the power -3. So it's gonna be 17.24 times 10 to the -9 meter cube per second. Then I have to find the velocity, which is the volumetric flow rate over the area, and I already calculate the area here. So 17.24 times 10 to the power -9 over the area, which is 7.07 times 10 to the power -6 2.438 times 10 to the power -3 meter per second. I will fill the table again with the volumetric flow rate in liter per second, which means this one, 17.24 times 10 to the power -6, and the velocity is 2.438 times 10 to the power -3. Then I will find the Reynolds number again, same equations for the laminar. It's rho velocity diameter over the mu. It's 1000 times the velocity, which is 2.438 times 10 to the power -3 times the diameter, which is 0.003. The total is over 8.9 times 10 to -4. Now we're gonna see if our experiment was working good or not. See, what I got is 8.2 2179, which is less than 2300. So it's supposed to be this laminar. It's not turbulent, but I think it's something went wrong with the experiments. So I will just keep going on and calculated the rest. Even it's mistake, so 8.2179. So I will just keep going on. I will calculate the turbulent flow, which is F equal 0.316 over the Reynolds number to power quarter. So it's gonna be 0.316. The real number is 8.2179 to power quarter. It's equal 0.1866, and the heat loss gonna be same thing is F times L times velocity square over D times 2G. So 0.1866 times the L, which is given 0.4, and the velocity that we got it here is 2.438 times 10 to the 1 minus 3 square. The diameter is given, which is 0.003 times 2 times the velocity of, or the acceleration of gravity, 9.81. So the heat loss that we got is too small, which is 7.5388 times 10 to minus 6 meter. Just multiply it with 100. Then we got it in centimeter, which is 7.5388 times 10 to the power minus 4 centimeters. So the F that I got here is 0.1866, and the heat loss is 7.5388 times 10 to minus 4. So please do the rest of the calculations and submit it before the due date. Is tomorrow at 12 noon, which is gonna be 21st of March 2020. So if you have any question, please send to me email. Thank you.